2-point size is the default interpretation of a feature of size, according to ISO 14405. In this video I will explain what a dimensional feature is, how to determine a pair of opposite points, and how to measure such a size using a cylindrical feature as an example. A linear feature of size is a geometrical feature that has its own linear dimension called size. This size can be, for example, the distance between two parallel and opposite planes or lines, the thickness of tube wall, or the diameter of a feature. The parameter characterizing a dimensional feature is its internal or external size. Each of them can be interpreted in many different ways, starting with local size, which having non-unique results of evaluation along and around a feature, through global size, defining a unique value along and around a tolerance feature, up to many possible interpretations. In the case of a shaft, the diameter can be expressed, for example, as a 2-point size, a maximum inscribed size, a least square size, and many others. However, according to the ISO standard, the default method of interpreting size is the 2-point size, the distance between two opposite points. But what exactly are opposite points? The 2-point diameter requires the use of enabling feature. A rear cylinder, being a non-ideal feature with phone deviation, must first be associated using the default method, the least squares criterion. Perpendicular to the axis of the associated feature, an intersection plane is created. It is primary enabling feature. The extracted integral line in such a plane is then, by default, associated as a circle. Finally, a straight line, called secondary enabling feature, passing through the center that the circle intersects the extracted line in two opposite points. The distance between them is exactly the 2-point size. There are many manual instruments that allow for 2-point measurements. One of the most common is the caliper. Such a measurement should be performed in several places in order to determine the limits values. However, it must be remembered that the results may not fully correspond to the precise method described in the ISO standards. And this is because it is practically impossible to situate the part between the measuring tubes in a way that accurately takes into account the axis of the associated feature. Another, more precise way to measure is to use a coordinate measuring machine, with software capable of calculating the size according to ISO. The measurement strategy should include such a number of distribution of points that each of them has a directly opposite point. Otherwise, the accuracy of the measurement may suffer. Among all the defined 2-point size, the maximum and minimum size will be reported.